All right, so anyways, using the tables. So the joy of using the tables when we go about this is that what we were trying to do is to figure out what the future value, the amount of money we were going to have in the future. So first off, FV. I will be writing this 2-letter acronym down frequently. It's called the future value, and it's how much money will you have in the future? In other words, when you're done investing and you've added all of your interest up and added it back to your principal, that's how much money you will have in the future, right? Because you get your principal back plus all of the interest when you invest, all right? So, we know the long way, right? We know how to find future value the long way. Please note, folks, that technically the long way is also the exact way. If you want to know exactly how much is in one of your investments, when you're calculating how much money you will have 4, 5, or 6 years from now, technically the bank will always do it this long way, okay? Where they'll calculate how much money you earn each period, add it, and then move to the next period, okay? We are not going to do that, okay? When you are using the tables, you will find the future value by doing this. That's it. All you have to do is multiply one number. The key is making sure that you find the correct entry in the table to use. Okay, that's the only tricky part about this particular portion of it now, is figuring out how to find the right number out of all of these numbers in our tables. Okay? So, that first example, what was our first example that we did last time when we did it the long way? What did we do? We invested...
Invest $5,000 at 4% compounded annually for 4 years.
5,000 at 4% compounded annually
For 4 years.
for 4 years. How much will we have? All right, so we know how to do this. We know how to do it the long way. We've done it the long way, so we actually have the amount. Okay? So, the question then is, how do we find the right value in all of these tables, right? Because, I mean, we're looking through all of these tables. There's a whole bunch of numbers floating around. What's the magic right number? Okay? How do we find the correct table entry? Well, the first thing you'll notice as you start flipping through the pages in your tables, what is on the very top corner of every page?
The percentage.
A percentage, right? A half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10, etc. Right? Sold. Isn't that how it goes eventually? Somebody buys it. All right? So we just have to figure out what page to turn to based on the percentage. Okay? The page is based on the percent of our, that's a U, I swear, of our interest earned in each period. So in this case, what percent were we earning?
4.
4%. So guess what page we turn to?
4%.
Good idea. So let's turn to the 4% page. So note, I will call this page the 4% page. The table will call it page 8 on the bottom. I am never going to use the numbers along the bottom, folks. I am always going to base my pages on the percentage along the top. So when I say what page, don't tell me it's page 17 or page 6 or whatever. Tell me it's page 3% or page 7.5% or whatever, because that's the important part about the page. Okay? So for us, our page is the 4% page. Now, guess which one of these columns we're going to use based on the title of the column along the top?
Compound value.
Compound value, because what are we calculating here?
Compound value.
The compound interest, and hence the compound value. So we are going to use the first column. Now, the first column over to the far left is the number of periods. How many periods were there in our example? 4. I will call this what row to look on. And this is just basically how many periods are there. So in this case, we have 4. So in that first column on the 4% page, the 4th row, what's our table value?
1.1699.
That's our table entry based on the formula. What do I do to figure out how much I will have in the future? Multiply by P. P is however much you're investing.
5,000.
What's 1.1699 times 5,000?
$5,849.50.
So look back in your notes from last Monday. What was our exact value?
That amount.
Is it the exact same number?
5,849.29.
29, right? So note that it's close. Note that it's not exact. And for this class, folks, I am happy with close. Okay? So on the homework problems, the way I expect you to do all of the problems is by using the table to do the calculations. Okay? That's how I want you to do it. The only time you don't have to use the table, folks, is when it asks for the exact interest. If the problem ever says, calculate exactly how much money you will have in a certain amount of investment, then you got to do it the long way. Okay? That's the only time you have to do it. Otherwise, table is always good. Alright? That's all there is to it, folks. Alright, so what was our second example that we did last time?
Invested $10,000, 6% compounded quarterly for 1 year.
6% compounded quarterly for 1 year. Okay, so so now let's use the table to do this, okay? So, theoretically, folks, what page am I going to go to?
6%.
6%, because that's what our interest is, right? What row on that page are we going to look on?
4.
Why 4?
4 periods.
There's 4 periods. So, On the 6% page, which is really page whatever, 13 or whatever that is, 12, okay? So what's the table entry on that page?
1.2625.
So everybody knows how to read the tables, right? Looking up the number. Great. Multiply by 10,000, because that's how much we invested, right? What'd you get?
12625.
12,625. When we did this the exact way, folks, how much did we get?
10,613.43.
Okay, here's the piece that I did not carefully explain to you guys. The page is based on the percent of our interest earned in each period. We are earning 6% over a year. But remember, how are we compounding this?
Quarterly?
How much interest do we earn in a quarter of a year?
Wouldn't you take the 6 divided by 4?
Take the 6 and divide by 4. What percent are we earning each period? 1.5%. So there's the trick, folks. Here's where the table is slightly tricky. It's not the actual percentage. What you have to do is take the percentage and divide by the number of periods per year for whatever method you are compounding. Okay? Because we are working with something that is quarterly, there are 4 quarters in a year, we're not going to earn all of our interest in the first period. We're going to only earn a quarter of it. So what we're really going to use is the 1.5% page. So if we go to the 1.5% page, what's our table entry?
1.0614.
Now multiply that number by 10,000 and see how we look this time.
10614.
$10,614. Is that a little bit closer than what we were at before?
Exactly.
Yes. Okay. Much better. It would suck if the tables actually didn't work, right? Because then you would always have to do it the long way, and, well, that would suck, right? So the key here is realizing that based on how many times you compound it, folks, you always have to divide your interest up by that amount.
But I don't understand why don't you have to do it like that when you do it the long way?
We did do it that way the long way, right?
Well, this one I thought it was just 6% compounded interest. Or for the first period we did 10,000 times 0.06. Oh, times
0.25. Exactly, right? So even when we were doing it the exact way, we were using that 1/4 value because we were always multiplying by 1/4, right? And then remember, in the last 2 periods, what did I tell you to multiply by? Of what we did last time.
The time and the rate.
Yeah, we multiplied the time and the rate. What was the time and the rate multiplied by getting you? The 0.015?
Yeah.
And what is 0.015 as a percentage?
1.5.
1.5%. So I was giving you a hint last time what we were doing about which page you were going to really go on, because essentially that's what we're doing, right? The number that you always multiplied by 0.015, that's the page you always want to be on. Okay? That's how the table works. Alright, so let's try another one and see how we do. Okay? Except you won't have to do it the long way, you can just do the shortcut. Okay? So let's suppose that I invest $8,000 at a 7% compounded semi-annually for 12 years. And note, I'm going to change the question on. Well, no, I'll do that in the next one. Okay. So, how much will I have? That's 7-2. Sevens can shift on me. So first off, what does it mean to compound semi-annually, folks?
Twice a year.
Twice a year. Okay, so every half of a year we're going to compound our interest. All right? So, theoretically, folks, since we want to use the tables, what page am I going to go to?
7%.
Start with 7%, but now remember, folks, how many times do we compound per year?
Twice.
Twice a year, so take that 7 and divide it in half. We're going to use the 3.5 or 3.5% page. And then technically, folks, how many periods are there?
2.
6.
40.
You guys are way out there.
Well, you're 60.
There's 2 times 12, 24 periods.
24 periods, yes, because there are 12 years, and there are going to be 2 compounds per year, 24 periods. And one of the things that I kind of like to do when I do these problems, folks, is to show you what happens. Right? Your page and your row are basically your percentage and your years, but then make sure that you convert them based on how you are compounding, right? So if you're compounding semi-annually, twice a year, you're going to only earn half of your interest in a period, hence 3.5%, but you are going to compound it twice as long, 24 times total, over that particular 12-year period. So, 3.5% page,
2.2833.
what do you get there? 2 point what?
2.2833.
2.2833. What do I multiply by?
8,000.
The $8,000 that we invested. How much money are we going to have 12 years later?
$18,266.40.
And please note, folks, that that is approximately, okay? This will be close, it will be within $1, but it will not be exact. If you need the exact answer, you gotta go through the crank of 24 times, right? Cha-ching, 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 right? You don't want to have to do that. This is why this is okay. All right? Not bad? Okay. Okay, so let's see. Let me try and throw a wrench at you this time. So this time, I invest, well, let's say, that's relatively simple, $6,000 at 6% compounded monthly. For 4 years. And now, note my question to you this time, though, is not going to be how much money am I going to have, but what I want to know this time is how much interest will I earn? So, what does compound monthly mean?
Split it
12
into
months.
months instead of quarters, so.
Yeah. So technically, folks, what page are you going to go to? What percent are you going to look up? We're going to start at 6%, right? But what do we have to do with that 6%? We have to divide it by 12, right? Because there are 12 months in a year. What's 6 divided by 12? Make sure you divide the right order. Right, it's not 12 divided by 6, it's 6 divided by 12, right? You're taking a number and dividing it by a bigger number, so you should expect it to be smaller than 1. Technically, how many periods are there, folks? What row are we going to go to?
72. 48.
4 times 12. There will be 48 periods of interest. Folks, you do not want to have to do this one the long way. Okay, that would suck. So, 0.5%, folks, that's literally page 1.
1.2705.
1.2705. Multiply by the $6,000 I invested.
7,623.
7,623. Are you done?
No, subtract it from 6,000 to find out your interest.
Okay, good. Note, remember that when you use the table, what you're generating is the future value, right? I asked for the interest. You got to subtract off the principal in order to do that. Since I made the number nice, it's not too bad. How much interest did we earn over those 4 years? $1,623. So please note, folks, don't forget then this basic tenet, right? The future value is the same as the maturity value, what we learned back in chapter 10. It's still principal plus interest. So even though we're talking about all of this compound interest crap, the basis is still the same, right? How much money you're going to have in the future is straight up principal plus interest. How much of that interest is earned as interest on top of the interest? Don't worry about it. Just tell me how much total interest you have, and I will have it. Not bad, right? So note, folks, we've done the 4 classic examples. Annually, which means you're compounding once a year, so you can just look the percent up straight in the table and you're all good to go, right? We did semi-annually. Which means that we're compounding twice a year, so you need to make sure that you cut your interest in half when you figure out what page you're going to go to. Quarterly tends to be the most common method that we compound things. Almost all of your 401ks, your IRAs, your investments that are of a standard nature will compound their interest quarterly, just so that you know. It's kind of the default. Monthly, which is the way most savings accounts compound their interest. Again, it's a mixed match of it to some degree. Be careful with it. Those are the 4 classics. There is a not quite so classic, but you can use it. most banks, just in case you guys wanted to know, will compound your interest in your savings accounts daily. It accumulates monthly, but it's actually calculated daily. All right? Now, granted, if you don't have much in there, it doesn't make much of a difference. But daily, theoretically,
352.
yeah. Well. Most banks compound daily at the 360-day level, which is actually a benefit to you, right? Because that means that your interest rate is slightly higher.
So is that because, like, is that, like, when you pay the interest, when you call it and pay off the balance, it shows on your credit card?
Well, this is investments only.
Yeah, but, like, when they do it daily, and then you turn around, like, when your bills and now you have a balance even though you don't have any money you spent, that's kind of the deal type thing?
Not quite. We'll get to that when we get to chapters 14 and 15, though, when we start talking about fees and penalties and things like that. That's more along the lines of borrowing money. This is more along the lines of investing. Now, note, folks, are you going to want to have to multiply and divide by 360? First off, how many rows are there on this table? 50. If we compounded daily for even a half of a year, what's 360 times a half? More than 50, right? So note that when you compound daily, technically, folks, you are not going to use any of these standard tables. You are going to use a special table. There is a special table dedicated just to compounding daily. It is literally page 36 in the tables, okay? So the number along the bottom of the tables is 36. So if you would just turn to that page, you will see the table that you use to deal with compounding daily, okay? So what I would recommend, again, you don't necessarily have to do this, but this is my recommendation to you folks, is put a little sticky note on this page and write daily compound. Because if you ever have a question that asks you how much or what you're doing with a daily compounded problem, this is the only page you should turn to, period. Okay? Page 36. That's it. All right? And note, the numbers have to fit somewhere on these tables. Okay? So, really quick, let's suppose that I invest, whatever, $5,000 at 7% compounded daily for 4 years. Okay? How much will I have? Basically, all you do, whenever you see compound daily, you think go to page 36 and just look the number up for the exact example you're working with, pull that number off the table, multiply, done. Okay? So, folks, what is the table entry for 7% 4 years that I'm going to multiply by?
1.2712.
Isn't it 1.3?
That's 6%.
231?
No, sorry.
Yeah. Make sure you're on the right column. And so that this, in this case, the percentage is just the number along the top, right?
I see it.
And again, just multiply by the 5,000. So whatever that works out to be, 67, 66, 65,
16.
66, 16, 50,
No. I got 6616.
6615.5. That sounds right. Definitely had to get a 50 cents in there somewhere. Think you missed the one at the end?
Sure did.
So, again, though, Don't worry about the multiplication and division by 360. You don't actually have to do it. You just use the special table. Okay? I know there's at least one homework problem that asks you to do a daily compound, so just don't forget this table. You're all good. Okay? So just whatever it takes, either write yourself a note, put a sticky note on the table, what have you. Make sure that you find the right page to deal with daily compounds. Alright. Not too bad. Note, folks, this only works if the interest rate and the compounding always stays the same. Okay? So there's a couple of times in the homework where the book is not 100% explicit that if it compounds monthly, that it tells you then that it's going to be monthly interest. Okay? So just realize that those two things are always going to be the same, right? The percent and the periods must remain the same for the entire investment. If they ever change, you need to stop and restart. Okay? So in other words, let's suppose that I do this kind of investment. Right? So let's suppose that I invest $5,000 at, keep it simple, let's say 5% compounded annually. For 4 years. Then the interest rate drops to 4% for the next 4 years. So it goes 4 years at 5%, and then for whatever reason the interest rate has to drop because the bank said, hey, interest rates are falling, we have to drop your investment to 4% for the next 4 years. How much will I have at 8? How much will I have after these 8 years? That's 8, I swear. Okay. So, how do you think we would do this problem, folks? 2 separate problems, very much so. All right? So what am I going to do first?
The first one.
Yeah, do the first investment first, which of course makes sense, right? So what page are we going to be on for the first part?
5%.
And note, technically, I am exactly on 5%. If you want, and I do this sometimes just so that students can kind of feel safe about it, in theory, we really are always dividing the percentage by something. It's just that when we compound annually, since it only happens once a year, we're dividing by 1, and that doesn't change stuff, right? So, in theory, you don't need to do that, but if you get in the habit of always doing the division, then you won't forget it at a later time. How many periods is it going to go through 5%?
4.
Yep. And again, this is just me being explicit. So what's your table entry?
1.2155.
multiply your $5,000. It was $5,000, right?
Yeah,
Okay.
6077 and a half.
$6,077.50. So what does this number represent?
Our new principal.
At the end of
4 years.
At the end of 4 years. So in theory, how much do we invest into the new?
That much.
So this number is carrying forward, okay? So this is our new principal for the next investment. So the second part, technically what page are we going to be on?
4%.
Now we're on the 4% page.
Row 4.
Still row 4 because we're doing another 4 years.
That was 1.1699.
1.1699. Yeah, because we did that one already, right? And now use the number that we just calculated to move forward, right? So this number is what our principal is. $6,077.50.
$7,110.07.
$7,110.07?
Yep.
7 cents.
I rounded.
And please round correctly. If it's 0.069, go up. If it's 0.073, round down, whatever. Just round correctly. So that's the idea, folks, is that if things change, you have to change with them. I mean, that's all there is to it. It works the same way if you added more money into this problem. Right? So imagine if we invested $5,000 at 5%. And then at the end of 4 years, I invested another $5,000. Anytime you change the problem, you have to make breaks and start over. Okay? That's just the way it's going to work. All right? All right. Not so bad? All right, so the table. Just basically remember the rule and you should be safe. Okay? Now, if you've worked in banking, you have seen this phrase before, or this 3-letter acronym, APY. Does anybody know what APY stands for?
Percentage per year.
Close.
Annual percentage yield.
Annual percentage yield. Essentially close to that, right? You don't have to say per year because annual means that, right? Does anybody know what that means? Please note that banks technically, by law, for any investment, must tell you what the APY of that investment is, always. So anytime you look at a banking website and they're looking at interest rates, they'll tell you something like, this is a 2% compounded quarterly investment, and it's 2.06% APY. So here's what it is, folks. It's interest from a compound interest account written as a simple interest number for 1 year. So, what the government discovered or decided about, I think it's 25 or 30 years ago now, is that we as Americans suck with compound interest. We don't get it, okay? We just don't. All right, and so what the SEC did, the Securities and Exchange Commission did, is they passed a rule that basically told all banks, anytime you create an investment account that has compound interest, you must convert the compound interest into simple interest. Because we as Americans understand simple interest. We get I equals PRT, okay? So if something's earning 2.05% interest, we know that we can take the money times 2.05% for 1 year, and that's how much interest we could earn in a year. Okay? We do not understand 2% compounded quarterly or 3% compounded monthly, we don't get that. For whatever reason, it goes over our heads, okay? Now, in theory, at the end of this class, or at the end of even today, you guys should know what it means, and you should be able to handle it. But, the average American walking along in the street, no, sorry, okay? So, what I want you guys to do is to figure out how to compute this. So, how do we compute APY? Alright? I'm going to show you the long way first, and once I show you the long way, I'm going to show you sort of a neat little coincidence, and then you're going to go, wait, is that coincidence always true? And I'll say yes, and you'll go like, oh yeah, good. And you'll see why, okay? Alright, so, let's suppose that I invest, let's keep the numbers simple so it's not a pain in the butt or anything like that. $10,000, nice easy number, at 6% compounded quarterly. I say find the APY for this investment. Okay, so in other words, take that 6% compounded quarterly and convert it to simple interest. Okay? The simple interest rate. Now, first off, folks, simple interest. I equals PRT, but we want to find the simple interest rate.
I equals PRT times 100.
I want the rate. I want R by itself.
Oh, I divided by PT.
R equals I over PT. Awesome. Right? This is what we need to calculate because this is simple interest, right? So this will be our APY. So for this investment, 10,000, 6% compounded quarterly, you got to give me these three numbers: interest, principal, and time. Let's start with the easiest one. What's the principal?
10,000.
Okay, good. Now, here's the one that's slightly tricky, but you should be able to get it eventually. What's the time?
4.
This is of the simple interest, not the compound interest. Here's a hint.
6.
Yes, what does the A stand for again? Annual. Everything is driven off of 1 year. So whenever you're talking about APY, folks, everything is 1 year. Because we can deal with ones, right? We know how to multiply and divide by 1. That's, again, why they make it APY, because that's a simple number for us to deal with. It's 1 year. And now here's the mildly tricky part. How do we find the interest that this investment is going to earn in 1 year?
Won't we use the table?
Good idea. Let's use the tables.
Won't we have been on the 6% page?
I equals use tables. Okay, so how are we going to use the tables? What page are we going to go to?
6%.
6%. And what are we going to do with that 6%?
Divided by 4.
Divide it by 4.
1.5 turns.
We're on the 1.5% page. What row are we going to go to?
4.
Because again, it's 1 year times 4, so 4 periods.
1.0614.
Table equals 1.0614. What do we do with that number?
Times it times 10,000.
Multiply by the 10 grand.
For 106.14.
What does this number again represent?
Future value, so subtract 10,000 from it for the 614 for interest.
Sweet. There's our I. Twing. So, what is our R going to be?
614 divided by 10,000.
Technically times 1, right? But
10614,
that's the rate. I want it as a percentage.
6.14.
There you go. So in an account that is paying 6% compounded quarterly, you will be earning 6.14% APY. All right? So that is the long, blown-out process for how you figure out APY. Now, here's the coincidence that I want to show you.
I noticed that.
Folks, that is not a coincidence. It will always happen. Okay? Now, why is this? Just a quick insight as to why it works this way, right? Technically, the way we were figuring out how much interest, what do we wind up doing with our table value to figure out how much interest? What do we have to multiply by? The principal, right? Well, if we're going to use the interest, we're going to find the interest by multiplying by the principal and then dividing by the principal. What happens when you multiply by the principal and then divide by it?
Get the same number.
It gets canceled out, and you go back to being whatever this number is. Therefore, this number will always drive your APY. It's not a coincidence, it's a fact. It'll always work. The decimal in your table lookup will always be your APY. And this is 100% all the time. And note that technically it has nothing to do with the amount of money you put in there, right? It really doesn't matter. Because we're going to multiply by that number and then divide by it. So if that number was 1,000,000, who cares? If it was 2, who cares? Right? Because we're going to multiply by it and then divide by it. It goes away. We're always going to get back to whatever our APY is. All right? So, yeah, just the decimal portion of it. Yes. Okay. The reason why you don't use the 1, folks, is because technically, what did we do after we multiplied by the principal? What did we do? We subtracted by it. Essentially, that's our minus 1. Okay? And that's why you just look at the decimal of the table entry. Okay? So, given this knowledge, find APY for a 9% compounded semi-annually account. Because now you don't even need to know a dollar amount, right? In theory, you know, the book will always say that you do, but you don't, right? So, you still pretend like you're going to do this the normal way, right? So, folks, you have to go to the tables. So, what page in the tables are you going to go to?
I want to get 4.5.
And why is it 4.5?
Because it's 9 divided by 2 is semi-annual.
There you go. Since it's semi-annually, still dividing by however many compounds, we divide by 2. Now, be careful here. What row am I going to go to?
1.
It's 1 year. But how many periods are going to be in that year?
2.
Because it's compounding semi-annually, so you have to look on row 2.
0.0920.
What was that, 0.0920?
Yes.
And so now, tell me what the APY is?
9.2%.
9.2%. Way better, right?
Yeah.
Oh yeah. I knew you guys would like this one. Okay? So that's how you do these problems, okay? Whenever you get an APY problem, to write 9.20, I'm okay with that. Those are fun. And there's at least one of those on the homework assignment, maybe even two, I think. And those are just like 3 points. Okay? Say thank you when you're doing it. All right? All right. So, not too bad. So, we have learned, folks, how to walk forwards, right? What? Once you've walked forwards, right, you teach your kid how to do that. It takes them like a year to figure it out, right? But then, once they get into kindergarten, what do they have to be able to do? They have to also know how to go backwards, right? It's one of those things that they're actually using it to test their inversion processing in their brain. It's one of those things that kids, if you don't make them think about it when they're younger, it takes them a lot longer to figure it out, right? So what a lot of kids will do when they say, well, walk backwards the same way, what will they do?
Turn around.
They'll turn around and walk forwards. And while that's not a bad interpretation, did they follow directions? No, because they turned around and walked forwards when the directions were walk backwards, right? And that's a problem. Right? If students aren't getting the directions and following them and saying, well, I can always take shortcuts and do the easier way. Nope. At kindergarten, they don't want you to do that yet, right? They want you to be able to follow directions explicitly. So if it says walk backwards, right? It's also why we teach them how to skip, right? Because what a lot of kids do when they skip is they do this. Is this skipping? No, that's galloping. It's an entirely different thing. So they have to learn how to do skipping, and they have to be able to figure it out so that they can mimic the pattern. Because if a child cannot mimic patterns, folks, they will not be able to do very much in life later on. So we got to get them going at an early age on things that are straightforward and physical, so that they can then do the same thing mentally, same concept. Okay. So, anyways, you guys need to walk backwards. So, how do we go backwards? Oops, I'm blue. Go backwards. And first off, what we're doing when we're doing going backwards, this is what's known as finding what we call the present value. Okay? So basically we're saying we know the future. We've already gotten there, right? And what we want you to do is to walk backwards to the present. That will then take us to that same future, right? That's the idea, right? Monetarily, what we're answering is how much do we need to invest now to reach a known value in the future. Now, why would we ever need to do this, folks?
Saving up or something.
Duh. Duh, right? Now, the classic example, this is the example I always like to start with, right, is my house will need a new roof in 5 years. So, I put a new roof on.
Apparently didn't do a very good job.
I put a new roof on 15 years ago, and I put on 20-year shingles. If I put on 20-year shingles 15 years ago, when do I need a new roof? 5 years, right? In theory. My new roof will cost $15,000.
Wow. You're getting wrong.
Well, I've got 2 gables in my house, and it's a rather long house, so there's a lot of square footage along the top. And I'm hoping that in the $15,000 I can also get new gutters, because my gutters suck.
Should just convert to a metal roof then.
I was going to say that.
Brings your
Tin roof.
insurance down.
No, I would think about it, depending on how much money I have when it actually starts rolling around.
Right.
So my question is, how much should I invest now at 6% compounded quarterly, so I can buy my new roof. In other words, not borrow to buy the roof, just pay it in cash, right? So the whole idea is that this year I played the lottery because it's a $750 million lottery, and say I don't hit all the numbers, I only hit like say 4 or 5 of the numbers, so that I win like $12,000 or something like that, right? I get a little windfall, a mini windfall, and instead of doing what you normally do when you win $12,000, and that's to immediately spend all 12,000 of it, you think about it and say, oh, that's right, I'm going to need a new roof in 5 years. I'd rather not pay interest to buy the roof. I'd rather earn interest to pay for the roof. Novel idea, right? So take some of that windfall that you got and invest it into the new roof, all right? So this, folks, is a classic problem where they're telling you how much you need in a certain number of years, and you're asked to go not into the future, but from the future back to the present. And that should have been the title of the movie, not Back to the Future, but really Back to the Present, right? Because when Michael J. Fox went to the past, he wasn't trying to go back to his future, right? He was trying to go back to his present time.
Back to the past.
So he went to the past, right? I mean, that's what his car took. The DeLorean took him to the past. He wasn't trying to go back to the future. He was going to go back to where he started, hence the present, which would have been a way better title for this problem. But unfortunately, it's not a really snappy title for a movie, right? Back to the present. Yeah, that doesn't work. Back to the future, and it sounds better. Bastards. Anyways, they should have called it Back to the Present. My personal opinion, mind you. All right, so folks, the key to this problem, folks, going backwards, that's what the second column of the table is for. Okay? So note what the title of the second column is.
Present value.
Present value. Hey, what do you know? Guess what you use to find the present value? The column titled present value. Go figure, okay? So the key here is realizing that present value just equals the future value times our table entry. But please note, use column 2, or what's its title number? 12-3. 12-3. Okay? That's what the second column of the table is for. It's going back to the present. Otherwise, folks, everything about the table, the way you look it up, the number, etc., exactly the same. So, guess what page we're going to go to for this problem?
1.5%.
Why?
Because you take 6 divided by 4.
Uh-huh. So the page you're going to go to, there's only one A in page. Sorry about that. 6%, since it's compounding quarterly, we're going to divide by 4. We're on the 1.5% page. What row am I going to go to?
4.
How many years is it till I need my roof?
5.
5. How many periods will there be?
3 quarters times 5.
20. Good. Okay. So the row, it's 5 years, right? But it's 4 quarters per year because it's quarterly. 20 periods. So now, what's our table value?
0.7425.
0.7425. Note that all of the numbers in the second column, less than 1, because we're working backwards. So we know we need to have less money than we think we do, because the interest we're going to earn is the difference, right? Times that by the $15,000 I need.
$11,137.50.
$137.50. So note, if I won $12,000, folks, I can buy myself a new roof in 5 years and have a little bit of money left over, right?
If you won, what are you actually, you're earning that?
Oh no, this is how much I have to invest, right? So if I invest this much money today, in 5 years,
That's right, okay.
I will wind up at $15,000. Okay? So that's how those backward problems works, right? So,
So you wouldn't in actuality have to use the entire 15,000. You could just spend that much money on your investment and keep the change for yourself, right?
in theory, again, depending on how you work on it. Right, so if I invest $11,137.50 today, I will have $15,000 in 5 years. So that's how that second column works. It's basically figuring out how much do I have to put in now to get to the number that I want to have in the future. All right? So, here's a great question. So let's suppose that, so let's switch pages. Let's go. I invest $11,137.50 into an account that earns 6% compounded quarterly. How much will I have in 5 years?
Isn't that just the first kind of problem thing?
This is like the first kind of problem, exactly. Okay, so good. Note that in this chapter, folks, technically what you need to be able to do when you read a problem is tell me which way you're going. Forwards or backwards, okay? If you're going forwards in time, like this problem, then you use the compound value column, right? That first column. If you're asked to go backwards, which was the problem before this, that's when you use the second column called the present value column. Okay? So that's actually technically the first thing you should do on every problem in chapter 12, is tell me which way you're going, forwards or backwards. Because if you're forwards, you use the first column. If you're backwards, you use the second. Okay? So in this particular problem, since we're going forwards, we're going to use the 12-1 table. Right, that's the compound value one. Technically, what page are we going to go to, folks?
1.5.
6%. Since it's compounded in quarterly, we're on the 1.5% page. What row are we going to go to?
20.
20. Because it's 5 years, 4 quarters per year, 20 periods. So what's our table value?
1.3469.
3469. Multiplied by your $11,137.50. $15,001.10. And why does that number make sense? Based on the problem we did right before us. What did we do right before this problem? We went backwards. And what did we decide when we went backwards?
That was the,
That this was the amount of money we needed to invest so that in 5 years we would have $15,000. And what did we just prove? That it's true, that it works. Okay? So note, that's what you do to check answers in this chapter, folks. Is that one column moves you forward. if you figured out whether or not you moved forward correctly, what do? You move backwards the exact same way, and you'd better get back to pretty close to where you started. Okay? So this technique that we just did here is how you check a problem. Basically, if you do a problem and then you want to check it, you say, hey, go the opposite direction and make sure you wind up where you started. Okay? So that's the idea behind these sorts of problems. Okay? And look for it. I think there's at least one homework problem that asks you, check the result from the prior question and make sure that it's true. So you have to go back, do the odd question, which is always my favorite, right? And then you check the odd one by taking the odd answer and going the other direction and making sure it gets you back to where the odd question started. Okay? That's chapter 12, guys. All right? So let me just give you a couple of extra problems to play around with, so that you can think about this. Let's suppose that I have this one, right? Let's suppose that I say I need $800,000 when I am 57 to retire. Okay? So for whatever reason, I've done some calculations and I've decided I need this $800,000 when I hit 57 so that I can retire. And that's one of our goals, my wife and I, is to retire early. Initially, we were thinking we could retire at like 50, but that's already passed. And I'm still here, so that didn't happen. So,
You're past 50?
yeah.
How old are you?
Look good for your age. I was thinking like
Us-
48, 50,
I was
somewhere in
thinking it
there.
was closer to my age, which is almost 40.
No, sorry, I'm 50 now. I get to play in the old guy division. All right?
Not
So,
a senior.
Close to the senior discount.
I'm already a member of AARP. I love getting their mailers every month. It's friggin' hilarious, right? Because they tell you things like, what kind of hearing aid should you buy? And I'm like, whoop, I'm not there yet. All right, so all right, so I need 800,000 when I'm 57. How much should I have in my retirement account that earns? Am I an aggressive investor or a safe investor?
Let's do aggressive.
Great, aggressive. Okay, that earns 8% compounded quarterly. At age 50, so I can do this. So basically I'm trying to decide, can I retire, right? Which is a question you guys should be constantly asking yourselves, right? Because if you can retire now, it would be really nice to just say, and walk out the door, right? I mean, or at least, say goodbye and then walk out the door, right?
Not
Whatever.
if I have to spend most of that 800,000 to pay off my student loans. I'm back to square one.
Well, we don't have that much as student loans. All right. So, excuse me. So, what type of a problem is this, folks?
Going backwards.
This is a backwards problem, right? Because I know how much money I need in the future. I need $800,000 when I'm 57, right? So this is a column 2 or 12-3 problem. So that's kind of what I would like you guys to do when you do problems in the homework for chapter 12. Read the problem and then figure out whether you're going forwards or backwards. That's the first step, all right? Now, once you tell me what column, what are you going to do next?
8 divided by 4.
Yeah, give me the page, right? Page is always driven off of the interest, so 8% since it's quarterly. We're on the 2% page. What row am I going to turn to?
28.
All right, good. Why 7?
Because that's how many years you have to get the money you want. or
Yeah.
invest the money you want.
I'm 50, but I want to know how much I need at 57, so that's in 7 years. So yeah, 7 times 4 is 28. So, what's my table value?
8706.
What was that?
8706. Or am I looking at 23?
2%, 28.
Number 28? Period.
5744.
5744. Okay, that sounds a little better.
I'll shut up now.
You saw where it came from, though, Allison, right?
Yeah.
Okay.
Yep.
So, multiply that by the $800,000 I think I'm going to need at age 57. So how much do I need at age 50, folks?
Is that what you said it was a goal? So $459,520.
So what my wife and I do on a regular basis, basically at the end of every year, we go and we say, hey, do we have enough money yet in our retirement accounts? If we assume that they're going to earn 8% compounded quarterly, and we've got this much in there right now at age 50, if I don't put another nickel into my retirement account, how much am I going to have at age 57? 800,000. So, in essence, I don't need to save anything anymore. So what can I do from age 50 to age 57 if I've already reached my goal?
Would my care about to die?
Yeah. I can say that 15% of my salary that I put into my retirement account every month, instead of putting it there, where can I put it instead? Yeah. Exactly, right? Uh-huh. A big cruise boat through the Mediterranean, right? So every year, I can take that 15% of my salary and say, instead of having to invest it, I can just blow it.
My father-in-law does that. He says, I'm getting ready to retire. And every year he buys something crazy.
Oh, well, yeah,
Like
that's true.
four-wheelers, quads.
Yeah, I know. If my wife would quit making us like buy floors and bathrooms and water heaters and house heaters and air conditioning units. If we could just live in a tent,
There you go.
I would be retired if I lived in a tent.
Look at it this way, now you probably won't retire. Now you probably won't have to get that stuff when you are retired.
That's true. Well, yeah, that's the problem too. Is that so built into our retirement is of course selling our house. I have a house in Madison that I've paid off, so a lot of it will be just selling the house and moving into a tent. The tent's just a little cheaper than a house living in Madison. All right? But anyways, these are the sorts of things that this chapter should start you thinking about. All right? So, but that's essentially chapter 12, folks. Note, all of this investment once, right? We're putting the money in once and things are happening. Is that the way real life works, folks? Do you just put money in once into your retirement account and then you never look at it ever again?
Well, if you win the lottery and you win $800,000.
True. But normally you invest multiple times. Guess what chapter that is?
Next one.
Chapter 13. And note, that's why there are 3 more columns inside of our tables. And note what the titles of all of those are. 13-1, 13-2, 13-3. Guess which chapters we learned those columns? Chapter 13. And that's all about investing multiple times. In this case, every period. How much money will you have if you don't put the money in once, but you put it in every quarter? Or how much do you need to invest every quarter so at the end of 7 years you have $800,000? Those sorts of questions. That will be answered next week in chapter 13.
And this is exactly why I don't work at Wall Street.
But you want to be able to have a basis for how to calculate this stuff. Okay, folks? This is what a financial advisor does. Their numbers are a little bit bigger, but honestly, they use the exact same tables we're using right here.
Are we going to learn how to determine, say you pay an extra $100 on your mortgage, what that does for you? over
That's
time?
chapter 15.
Okay.
So not until after the next test.
Okay.
That's,
So-
that's like chapter heading. Me and my husband do that every time we get something. Like, how do we beat the interest?
That's right. But note that this test is all about investing. So we're going to be learning about earning interest mostly in these first chapter 12 and 13. Chapter 14 and 15 is where we borrow and we learn about paying interest, which is much crappy.
Less fun.
Depressing.
Yeah, it's more real, I guess, is the right way
So
to
we all
look at
decided
it.
we're just gonna buy mopeds and move into tents.
Yeah, exactly.
Very sorry.
So again, please work on the homework for chapter 12 for next week. It's not a long assignment, but
You're the one that got squeezed through there.
I know.
Why, in the middle.
does it go up to 40 in this one?
I think it's like 30 something.
It's only 30 something? Oh, how depressing. These are the fun problems. This is the kind of one where you want to do a whole ton of them. All about earning interest. Oh yeah. It only goes to 30.
I'd like to know.